Yet, currently, if you actually measured the constituencies at the wellhead, could you not develop a model that was accurate?
Well, it would be this way.
It would be this way, but it wouldn't be these figures.
Probably not, but certainly the methodology for putting this, you know, that they did a...
Yeah, no, I'm not arguing the methodology. I'm just saying that if we had current data from the wellhead.
Oh, yeah.
Yeah, then, and I'm just telling you that the man who did this report did not like the data that was gathered.
No, I understand that.
Yeah, okay.
Use the microphone, please.
There's somebody right behind you. Yes.
Microphone, Jim. Jim?
Mike.
Microphone. Microphone? Stay behind.
Yeah. Sorry.
Jim, I think you touched on it in your lecture, but it went by pretty quickly and I didn't quite get it. Could you elaborate about in what sense geothermal resources in the East Rift Zone are or are not renewable?
That's what this slide, so how fast is the heat being added? And so if we work out, you know, if we take the amount of magma we think is coming up from the mantle and how much gets left inside the volcano as opposed to how much is erupted, that's where we come up with this several gigawatt thermal number. So that's the overall thermal energy that's being put back into the volcano. If we then work out how efficiently that energy is extracted by water going through a permeable medium and all that sort of stuff, we get down to the 100 megawatts of electric energy. So in terms of the best estimate we would have now is that 100 megawatts of electric, that's what the renewable is.
Over what period of time?
It's a rate. It's already a rate.
It's 100 megawatts per what?
Yeah, it's already, a megawatt is a rate of energy.
Right.
And so, you know, you would balance that against the fact that...
Okay, I see what you're saying.
Yeah.
But, so that kind of tells you what the heat flow is, yes? But you made the point earlier that you need three things for a producible resource.
Right.
And it's not just the heat. It's also the permeability,
right,
and the presence of water. So those can occur in fairly complex relationships.
Right. That's in part taken into account for that 100 megawatts. Because that's, you know, the E there indicates that it is an energy, electric energy extract from it. So we've attempted to look at the efficiencies of how to take heated water, you know, it's a 10% efficiency roughly, converting it to electricity. What's the efficiency of going from magma to hot water within a standard permeable system, that kind of thing. There's of course a lot of errors you can make along the way, but that's sort of the best guess we have at the moment.
Right. So you have 100 megawatts of heat flow.
Of electrical production potential.
Okay, that gets a little bit more complicated because you have to have the right arrangement, if you will.
Right. And again, we made some assumptions to get that number.
Right. So.
Why don't you and I talk afterwards?
Yeah, I'd love to.
We'll get on another question. Yes.
Yeah, you said that Kauahikaua emits 2,500 tons of hydrogen sulfide a day?
On average, yeah.
Okay, and that the
25.
emitted 1.25.
25.
Oh, 25, yeah.
25 tons. Oh, I thought he said 2,500. Okay, so you said it emits 25 tons of hydrogen sulfide a day, and the blowout was emitting 1.6 tons per day. But I don't smell the rotten eggs up here. I do smell the sulfur. And isn't that hydrogen sulfide quickly converted into something else, which is quite different than when it comes out from deep in the earth through the well?
Okay, yeah, I'm gonna take that. So you're correct. You don't smell. Well, there are multiple reasons for not smelling
use the
the
mic?
hydrogen. Pardon?
Could you use the
So addressing a question, if there's 25 tons of H2S that comes out of the volcano on a given day, one, A, why don't you smell it? And B, what happens to that? The H2S, part of the reason you don't smell it is because it's coming right out of Halemaumau. That gas is being, most of the time, say 90% of the time, is being carried to the southwest. And so certainly up where we are now, you're not going to smell it. You're not going to smell it unless wouldn't have a chance of smelling it unless you're someplace like Pahala or Ocean View. And part of the other thing that I think you alluded to is that H2S, when it comes out of the volcano, it actually undergoes a reaction with sulfur dioxide, which is there in a much greater amount. So H2S, hydrogen sulfide, sulfur dioxide, SO2 combine to form native sulfur and water. So that
we're not breathing that H2S like we were during the blowout because it's being converted. Because I've been in Pahala and I don't smell the rotten egg smell. And you can smell it at 5 parts per billion or lower even. And we don't smell. I mean, any other people can maybe say if they are, and I'm wrong. But I've been up here. I've lived here for quite a while. I don't smell the rotten egg smell, which we should smell at 3 to 5 parts per billion. And we smelled it. It was very, very acute down during the blowout where we lived, and it's quite different.
Right. Here, what you say is so, well, there are multiple reasons for that. One is the chemical reaction that I just described to you, where H2S reacts with SO2, forms sulfur, which does not have an odor. And then, yes, it's converted to something you cannot smell. The other thing, let me finish, please, and then I'll take your follow-on question. The other thing that's going on is that the same plume that would hold the H2S also has a much higher abundance of SO2. And so the SO2 does tend to mask the smell, the odor of H2S. So, and I'm sorry, did you have a follow-on?
Well, basically, if it's converted, it's no longer H2S.
Correct.
Okay, and if we're not, it just doesn't seem to have the same impact as what was happening in the community down there when we had the well blowout. It seems completely different. And like I said, I've been in Pahala, I've been all around it, and I have been in Leilani for 30 years, so I've experienced all of this HGPA, the blowouts, all of that many, many times. And it really just seems quite different to me, and I'm having a hard time understanding if we're putting out, 8 times, more than 10 times, like 18 times as much, why we're not having those same impacts.
And I think the reason for that is that the gases that are coming out that are affecting the areas that are downwind of Halemaumau, the effects are from the sulfur dioxide. And there are definitely, I think we all know in this room that there are tremendous effects from the SO2 that are in Ka'u, well, they're all the way up to almost to North Kona. So the effects will be different because they're different gases, and health effects are different, and the effects on the environment are different.
Okay, just one more question. What are the H2S readings that you get in Pahala and these others where you're saying that we're getting this? If that's the case, there must be monitoring. So what are those monitoring showing? What are the H2S, not the SO2, but what are the H2S readings?
Okay, to my knowledge, in Pahala, see that the air monitoring that's being done in Pahala is being done by the Department of Health. In Pahala, in Ocean View, in South Kona, in Waikoloa now, the measurements that are being made there are all for SO2. They are not for H2S. H2S is not being monitored in those communities. What I can tell you is that because we measure the emissions from the volcano right at the source, that the H2S values that Jim mentioned earlier are what they are. They're like 2 or 3 parts per million, and in that environment, in that same environment where you're measuring 3 parts per million of H2S, you're measuring 300 parts per million of SO2.
I'm sorry, you're just making these more questions than it.
Okay, sorry.
Stop me. But at the wellheads, we're hearing they get between 1,100 and.
Why don't you come up afterwards and we'll talk about it? I'm sure there are other people that have questions too.
Okay, yeah, but let's do get together afterwards, okay? Anybody else? Thanks.
Yeah.
Jim, I read a paper on the fact that the hot water interacting with magnet can corrode and cause radon to be entrained in the hot water, resulting in the scale coming up with the total dissolved solids you talked about, including radioactive material. It's a thing that they're just starting to become concerned about on where they're digging in oil rigs. You know, if there have been any measurements of that for the geothermal community here?
What I can tell you that I know about radon is that thus far is that the radon emissions measured on Kilauea have been very low. I don't know what the radon measurements are down in the geothermal area, but radon is among its other characteristics, it's highly water soluble, and so that's really about all I can say about that.
There could be a potential that over the years within in the scale we would be accumulating some radioactivity.
I don't think so. I don't think so, and the reason I say that is because radon as a gas is highly water soluble. So radon itself is going to dissolve. It's going to have a greater tendency to dissolve in the water, and it's not a corrosive gas the way hydrogen sulfide and the way sulfur dioxide are. It is, as you say, it's a radioactive gas. It's present at low levels, and it's likely to dissolve in the water.
Yes, sir. The paper I read, they call it NORM, normally occurring radioactive material, and then when they drill into hot water resources in oil fields, which happens, then they found that the scale, when they removed the scale from the various equipment coming out of the wells, that they found that there's radioactivity in that scale. And if they take that scale and they keep putting it the same place, it causes a concentration of radioactivity, which eventually becomes more than a nuisance. They're trying to determine how to regulate it. And I was just wondering, it seems like the same physical things are in effect in our geothermal wells. I just wondered if it had been considered yet.
Yeah, I can't comment on whether or not they're the analogous processes. One thing I just add is, for instance, back on the U.S. mainland, where in certain places, especially on the East Coast, where radon emissions are known to occur, people who gather water out of from shallow wells there find that you step into the shower in the morning and you take your hot shower with water that's drawn off from 50 or 100 or 200 feet, it causes the radon levels in your shower radon levels from your shower adds a lot of radon to the room. So I wish I could answer that question more thoroughly.
Yeah.
Well, okay, kind of a two-part question. Isn't that the thing right there, though, is that you're bringing the radon up from a very, very low part of the Earth? And also, doesn't radon have a pretty short half-life, and it breaks down into some other things, doesn't it?
I guess I want to think about that. So you're bringing, I guess, one of the things to remember about this, the power generation system as we understand it, is that the notion is you bring the fluid up, you exchange the heat from it, and then you re-inject the fluid. It is true that radon does emit radioactivity. A substantial part of that is alpha particles. So
including lead, right?
Lead is an element. An alpha particle is a tiny energy particle. But the point being, I guess, in this response is that you're bringing fluid up, you're extracting the heat from it, and then you're re-injecting the fluid at a greater depth. That's the idea, the notion behind a closed system, which is what the power generation here is targeted to be, it is and is targeted to be, versus the kind where they take it and flash it into steam and it goes out into the atmosphere. So the times when when the problem with call it catastrophic gas release would occur would be when there's a blowout, such as was that Jim went over regarding 1991.
Hey Jim, based on our video availability here, we're going to go with 2 more questions, and then by all means stay and talk. I'm not trying to cut anybody off. We're just based on our podcast. So 2 more questions.
How close to the existing wells would you move you and your family and your children in and live? Would you feel safe and make that choice?
I don't know, I don't really like that area.
If you love the area, would it be, how significant of a factor would it be?
You know, I can't really answer that because I haven't been down there. You know, I read the accounts, I read the newspaper articles. It doesn't sound like fun.
Okay. How about you? Would you like to answer it?
Oh, Jim can move his family as close as he wants.
Okay. You wouldn't move
I have a nice
Yeah,
spot.
Jim, I recently came across an article where they did some satellite imaging, for lack of a better word, on subsidence in a geothermal area.
In this geothermal area?
Yeah, in California.
Oh, okay.
And I'm wondering if there's any possibility that USGS could do a similar satellite study on an ongoing basis, because it's been there for a while, and monitor it over time to see if the subsidence is significant.
You're talking about subsidence.
Right.
Got it. Because satellites do a lot of things.
No,
Yeah,
just
subsidence.
subsidence.
And we actually do monitor it. Right now we're in a sort of blackout phase because we used up our quota of satellite radar imagery from one vendor, and we're just starting to get another one, which means we had to change out our software reduction stuff. But we should be back online pretty soon. But we do look at that area, of course, because the subsidence, as you talk about, is one of the main indicators of future volcanic activity. But we also do a lot with GPS. We have GPS receivers cemented in the ground all over the east side of the island. We do campaign GPS every year, which means that we take GPS receivers out and we occupy a site for, say, 2 or 3 days to get enough so we can sort of estimate the movement on a yearly basis, and then sort of fill it in with our continuous GPS measurements. And with all of that, we integrate that radar interferometry, which tells us those other kind of movements. And the advantage of the radar interferometry is we get as full spatial coverage as is possible. We still can't, for the type that we're using, we cannot see through vegetation, but all the unvegetated areas, for sure, we can see whether they're moving. And then integrating that with the campaign and the continuous GPS, we actually have a pretty good picture of that sort of stuff.
And has it been significant?
In the East Rift Zone, no. Overall, for the last, since we've been doing, you know, the older technology was regular survey and leveling type stuff, and the entire East Rift Zone was subsiding up until just a few years ago. It was just a linear curve, and that's concerned the people in the Kauahikaua beach lots, because you know, there was an area where the coastline just sort of sloped into the ocean, and so any subsidence in that area would mean that the sea level will kind of move in closer. Most of the rest of Puna has cliff coast, and so even though they are still subsiding, and some of them are subsiding faster than the Kauahikaua beach lots, you don't notice it as much as these areas that slope right in. So we know that rift zones are subsiding, but as I said, for 10 or 15 years it was subsiding at a fairly regular rate. I think in the last 5 or so years it seems to have slowed down, but the data has gotten kind of sketchy. But we keep looking at it.
What was the rate?
Yeah, I don't remember offhand. You, Frank? Yeah, sorry. Okay, that was our 2 questions. I guess we run out of tape for some reason.
means hang around for a while and come on up and talk to these guys if you've got questions.